In this section, we are going to learn how to distinguish where a vertebrae comes from in the vertebral column. And we're going to start up at the top with the cervical vertebrae. They're numbered 1 to 7. The first one is the one that articulates with the skull. And it's a very special and distinct bone, and it's got a special name. It's called the atlas. C1 meaning cervical number 1. So it's the first cervical vertebrae. We number them from top to bottom. And the atlas is named for the Titan who was condemned by Zeus to hold the heavens on his shoulders. Now, I just want to clarify something. You may have seen pictures or statues of Atlas where he's holding the earth on his shoulders. That's not correct. He was supposed to hold the heavens on his shoulders. The ancient Greeks believed that the heavens were spheres that were circling above us. So he had to hold them up. And some people then saw the sphere, and then when we learned the earth was round, they made it into him holding the earth up, but that's ridiculous because he wouldn't have anything to stand on, would he? See? Makes sense. No, he's standing on earth, he's holding up the heavens. Anyway, your atlas is standing on a vertebral column, holding up your head. And it has a big hole, a big vertebral foramen for your spinal cord. It has big superior articular facets that articulate with the occipital condyles on the occipital bone. Remember, those are the ones on either side of the foramen magnum. So those create the occipito-atlantal joint. Occipito, obviously from occipital bone. Atlantal is the adjective form of atlas. Okay, so why atlantal and not atlal? That's kind of hard to say. Probably, that's why. Anyway, so the occipital atlantal joint is between the superior articular facets of the atlas, or C1, and the occipital condyles of the skull. And that enables you to nod your head. Yes, I understand. Now, this does not look like a normal vertebra, does it? This is the anterior side, this is the posterior side. There's no body. Like, where's the body? All that's left is this little tubercle. The tubercle is a kind of roundish, ovalish lump. Tuber comes from the same root as, tuber, which means root vegetable like a potato. Okay, so it's sort of a potato. Anyway, what you're going to see tubercles, tuberosities, they're all sort of vaguely potato-shaped. So we have an anterior tubercle instead of a big body. We have transverse processes that are very short, and we see a characteristic that is common to all of the cervical vertebrae, and that is foramen in the transverse process. Those foramina are going to line up and create a series of holes that the vertebral artery and vein travel through. So transverse processes indicate cervical vertebrae. The posterior arch has a little tiny posterior tubercle instead of a spinous process. Okay, so when you see something like this, just kind of looks like an oval or an eye, maybe, I don't know. That's the atlas. That's number 1, C1. The next one also looks really weird, and it has a special name, and it's called the axis. Now, an axis is something that, say, a wheel or a circle turns around. The axis is going to enable your head to rotate left and right. It is C2, the second cervical vertebrae. And this dens is a vertical process that sticks vertically up from the body of this vertebra and articulates with the atlas. And I'm going to show you that in just a minute. Okay, so that's the anterior side. This is the posterior side. And notice the spinous process has this little notch in the middle. It's called a bifid spinous process. Bifid meaning it is bifurcated. Okay, so that is something we also see in all of the cervical vertebrae, except the atlas, of course. Notice transverse processes with transverse foramen, one in each. A big articular facet, both superior and inferior. Okay, so that's the axis, and this is how they go together. So the dens is on the anterior side of the bone, just above the body of the vertebra, and you can see that it goes up against the front of the atlas, and these smooth facets enable these two bones to rotate left and right against each other. So it looks like this when you put them together. There's a ligament, a transverse ligament that holds the dens against that anterior side of the atlas. And then the easiest way to see this is actually in an x-ray, is to take an x-ray through the mouth. Isn't that wild? So here's teeth. Yeah, look at that. And this is, oops, sorry about that. This is the dens sticking up there. And here's the atlas. You can see these two facets, okay? The inferior articular facet of the atlas, the superior articular facet of the axis. Okay, so that's how those fit together. Now, if you break your neck, then you can get a cool little metal thing in your neck to straighten it. This is someone who broke, I think, C2 to 3, there's 3 to 4. But in their really cool CT scans, you can see, here's the dens up against the axis. We're just looking at a cross-section through the axis, and the atlas, and the atlas up against the occipital condyles there. Okay, and then if we look from the top, this is a superior view. There's the dens. You can see this really distinct outline of the atlas with the little vertebral foramen on the side. This is another more inferior cervical vertebrae with the transverse foramina and then the kind of bifid spinous process. All right, so all of that together, the body is kind of ovalish, sort of maybe like a kidney bean. Transverse foramina, short transverse processes, a bifurcated or bifid spinous process, and the superior and inferior articular facets kind of going more up and down than front and back. The other way you can distinguish the cervical vertebrae when you look at them is that they kind of look like a fish face. Okay. Oh, there's one more thing. I need to put this somewhere else. I always forget about this. The spinous process of C7, that's your last or lowest cervical vertebra, makes a bump at the base of your neck. And so you can really clearly see that spinous process there. That bump on the base of your neck, that's called the vertebra prominens, and that's made by the spinous process of C7. Okay, so cervical vertebra look like a fish face, or Sid from Ice Age. I know, right? Okay. Yeah, I got a whole series of these. Okay, next up is the thoracic vertebrae. As we can see now, we've lost the foramen in the transverse processes. The spinous process is no longer bifid, it's much narrower. The body is more heart-shaped. And then the other really distinct feature of the thoracic vertebrae are what we call costal facets. There's a costal facet at the end of each transverse process on the back side. Okay, this is where costal means rib, so this is where a rib is going to articulate. There's also a costal facet on the top of the body and a costal demifacet on the bottom of the body. And it's okay if you just call it a facet, I don't care. So the rib is actually the head of the rib articulates between the two vertebrae. So the head of the rib is going to go kind of here. And then the rib comes out to the back. Remember, the spinous process is the posterior side. The rib is going to go backward a little bit, articulate with the transverse process at this costal facet, and then swoop around to the front of the body to create the rib cage. Hang on, that'll make more sense when I show you a skeleton. So, body shaped like a heart, costal facets on the back of the transverse processes and on the body. T11 and 12 lack the costal facets on the transverse processes, but still have them on the body, and that's because of those ribs are a little different. No transverse foramina. The spinous process is very long, and notice that the spinous process points down. Okay, and because of that, it kind of looks like a giraffe. See? Oh, long giraffe nose. Yeah, right? It's even got like the little ears and the... Okay, anyway. All right, the last set are the lumbar vertebrae. Now, just like you put the largest person on the bottom of a pyramid when you're making a pyramid, these are the biggest and beefiest because they're holding up everything else. Yeah, sure, Atlas gets all the credit, but who's holding up Atlas, huh? Yeah, all these lumbar vertebrae. So the body of these bones tends to be very large, more oval, very tall. They do sometimes get this little curling on the edges. That's actually normal, although it can cause pain if it impinges on joints or anything like that. The spinous process is short and tall, very blunt, kind of bulbous at the end sometimes. Short transverse processes, and then the superior articular facets are on the transverse process, and the inferior articular facets or processes come off of the spinous process. And these face forward and back. So the superior and anterior facets actually go forward and back. So they look like this, oval or circle body, no costal facets, no foramina, very blunt, and looks like a moose. See? Looks like a moose. Okay, anyway, I got all of these from an osteologist who has a blog about it. So you can go to her blog there. I think it's still there. All right, so that's that. And up next, we are going to look at the sacrum and the coccyx and see how all of these features of the vertebrae, are seen still in the sacrum.